Guys, it's me again. As I hope you saw on our GroupMe group, and thanks to Caleb for catching this. Guys, I made a horrible mistake as we were looking over this mess. You may remember Bailey asked the question about voltages and one being this whole connection back to reduction potentials. And yeah, without making excuses, my thinking was actually exactly backwards because sometimes we think about these in terms of oxidation potentials as well. I know that means nothing to you, but guys, I got this absolutely backwards. So what I want to do is go back and talk with you about how these voltages, these reduction potentials, determine which side will be the anode and which side will be the cathode. And then we'll come back and we will take those ideas and apply them to the thing that we were talking about with Bailey. So, guys, when we talk about reduction potentials, we understand that reduction is the process of gaining an electron here, let's write it. So reduction is the process of taking in electrons. So you've got some ion, we'll call it X plus, and this thing takes in an electron and it becomes X. So the reduction potential is the potential of this thing to go through that process of gaining electrons. And so and this is the part that I wish I could share with you, but we don't do this anymore in AP, which is a little frustrating, is anytime you think about relative values, those relative values hover about zero. And so we have positive values and we have negative values for reduction potentials. And so when we look at reduction potentials, we can have an example of a place where we have two positive reduction potentials. When that's the case, whichever one has the higher of the two positive reduction potentials will be the one that will be reduced, that will be the cathode. We can also then have an example where we have two negative reduction potentials. In that case, the one that is less negative, larger, less negative, will be the one that is the cathode, the place where we have the reduction. Then we have the example of one where we have a positive and a negative. And when that's the case, it will be the one that is positive that will have the higher reduction potential and therefore will be the cathode. So it's always the number that has the largest value that will be the place where reduction takes place and will therefore be the cathode. With that in mind, as Caleb pointed out, and guys, I'm sorry this is such a mess, I'm going to rewrite it. So X was on the left, and that was negative 0.9. So let me switch to a thinner pen. So the way that we did this, so we put so we said this is X, and this had a reduction potential of negative 0.9 volts. This we called Y, and we said that this was negative 0.20 volts. And guys, this is where I made the mistake. This number is larger, therefore this is where the reduction will take place. Therefore, this is the cathode. This is a smaller reduction potential. Therefore, this is not where reduction takes place. Therefore, this is where oxidation takes place. And this is the anode. So again, Negative 0.2 is bigger than negative 0.9. So this is where reduction takes place. So that reduction will then be y plus becoming y. And then here where our oxidation takes place, x will become x plus. This will then be over here on the left where the electrons will be coming from. Those electrons will then move from left to right, coming over here and causing the reduction. So if you take that idea then, and I'm going to grab something that hopefully stands out really well, because you'll notice that I did this exactly backwards. So the idea is that, again, this is the larger value. That means that's where our reduction takes place. That means this is our cathode. That means, guys, this voltage actually is traveling, this current is traveling from right to left rather than left to right. So, I mean, forgive me, but everything that we talked about was exactly backwards. That this is our cathode. So the thing that we know is our larger value for the reduction potential is where the cathode will be. And then at that point, the whole conversation was right on. It was the mistake that I made in my thinking about this being the bigger number, the more negative number, and therefore where the cathode and the reduction is. And guys, that is not the case. So the number that has the larger value, again, coming back to this idea, the number that has the larger value, whether it's the larger positive value or the larger negative value or the one that's positive versus a negative, that is your cathode, and that is where reduction is taking place. So in that line of thinking then, if we go over here for a second, and if we look at this homework assignment, this is where Caleb and I firmed up this idea. If you look here at the solutions to this homework, here's a great example of this. If you look at number 39, and then if you look at A, it gives us these reduction potentials. And our first battery is a silver chromium battery. So here we have silver and here we have chromium. So you'll notice that silver has a positive reduction potential of 0.799. Chromium has a negative reduction potential of negative 0.74. So silver is larger, therefore that makes this our cathode where reduction happens. This is smaller, that's our anode where oxidation happens. Our voltage is then cathode minus anode, plug in the numbers and there you go. So then guys, if we look down below, I'd like to talk about this one. So we've got the nickel chromium battery. And if we look at our nickel chromium example, you'll notice that in this case, nickel is our larger, right? It's our larger reduction potential. It's less negative or larger. So that makes this our cathode. That makes this one then our anode. So looking down here then, if we go cathode minus anode, our cathode is the larger number, meaning, here, let me get that out of the way. Our cathode is our larger number, meaning our less negative number. So our cathode value is the value for the nickel, and our anode value is the value for our chromium. So guys, again, bottom line, bigger number is your cathode. I'm so sorry for that mistake. If you need more support or have questions, please let me know. But yeah, I hope that we're able to track this backwards and make sense of that. So be in touch if you need. Guys, have a wonderful spring break. Don't forget that you have a homework to record. And then on Monday, you have some hours to record. And then next Monday after spring break, hours to record. And then we'll get back together on Tuesday and we'll talk about the AP test. So, guys, again, thank you. Sorry. Nice job, Caleb. Have a good break.